Let's take a detour for a moment and talk about coercion of values. So, as you run your different regressions and as you crunch the numbers, whether or not you should use not a number or a specific value, for example, turning a dash character into $17 an hour, whether or not a specific value or not a number is a better fit for your replacement is going to depend on your analysis. Keep in mind, anytime that Pandas sees not a number, that row will be dropped from your correlations, your regressions, your summaries. And as soon as you provide a tangible number, that will be included in your regressions, your correlations, your summaries. My suggestion is to choose a replacement value that minimizes bias. Let's take a look at the effects of replacing not a number with different values. We're going to use a made-up data set. In the following examples, we'll take a look at generatedfile.csv, and the source code which generated this file is available on the Learn website. We have two columns, year and count, and some of the rows have the value less than 60 as a sentinel value. And our count range ranges between 61 to 124. So let's take a look at what happens if we replace less than 60 with discrete values. To start with, let's take a look at the original regression. So we try to see if we can determine a relationship between year and count, whether that relationship is significant, and what kind of predictive model we get. So in our original model, our regression results are as follows: fairly low adjusted R-squared and significant findings for year versus original count. Now, what happens if we replace all the less than 60 values with 0? Keep in mind, there's around 20 values that will be replaced with 0. What impact will this have on our regression? Well, here it is. Our adjusted R-squared has decreased. Our significance has remained the same, but look how much our intercept and our year coefficients have changed. I'll flip back and forth between the two slides for a moment so you can see the magnitude of the change. By substituting 0 for not a number, we have significantly changed our model. Let's take a look at this visually. What does this look like? On the left-hand side of the screen, we're taking a look at the distribution of data where we've substituted 0 for not a number. Notice how our data now has a very heavy left-hand tail versus the data set where the count, where we had not a number in our count. Our data is somewhat normally distributed. So we have impacted our analysis by pegging not a number to be the value 0. Now, what happens if we decide to replace less than 60 with the value 15? Well, our adjusted R-squared is a little bit better. But again, our intercept, our year coefficients are quite different from our original model. I'll flip back to the original model's regression results so you can see them. And I'll flip back to the 15 replacement. Take a look at how much the coefficient changes. And again, if we look at our data on the left, we still have this very heavy tail. And our regression result is quite changed. What happens if we replace less than 60 with a value that's dead in the middle, 30? Well, again, our adjusted R-squared has gone up a little bit. We're still statistically significant, but our coefficient is still quite a bit different from our original model. Again, we have a very heavy tail, although we're starting to get closer to our original data. If we replace less than 60 with 45, our adjusted R squared has gone up again, and our coefficients are getting closer to what we originally had. Again, we still have a very heavy tail. Now, what happens if we replace less than 60 with the value 60? Our adjusted R squared has gone up again, and our intercept now, the coefficient for our intercept in our year, is starting to get closer to our original model. Let's take a look at our original model versus replacing less than 60 with the value 60. Notice the coefficient changes slightly. We have a very heavy tail distribution of our data. If we compare all of the model coefficients, we see that if we peg anything that's less than 60 to be the value 0, our intercept and our year coefficients are almost double what they were for our original model. As we move up and treating less than 60 as equal to 60, we get closer to our original intercept or year. But with all of these replacements, we have introduced potential bias into our model. Look how much our predicted values change when we plug in the year 2021 and try to compute the predicted value. When we have less than 60 equal to 60, our prediction is 92.98 versus 112 when we're just omitting any data where the value is set to less than 60. The punchline here is you need to be careful what value you choose to substitute for not a number. More specifically, you need to be careful when you get a sentinel value and you decide to make a replacement. Not a number will be dropped from any regression analysis, but a discrete number. For example, when we were substituting 15, 30, 45, 60, 0 for the sentinel value less than 60, this biases our results. So any of our values that we substituted skewed the data and modified our model. And this introduces potential bias into our results. Remember, our data cleaning only talks about data being able to be read by the computer. It doesn't talk about whether the data is accurate. Python will run regressions on whatever values you throw at it. It is up to your judgment as a human being to make data substitutions. When you make data substitutions, always try to introduce the least bias. Always try to introduce the least bias. Remember, your substitution could have a major impact on your model. Look at the difference between predictions in our original model versus all of the different substitutions.